Sometime last year, we've talked about this, the smallest flying robot ever created by anyone, anywhere. The smallest flying winged robot, that is. A tiny fine apparatus that, at least in theory, could be used for a lot of different scientific studies, especially because it just so happens that it doesn't just fly well, but it also is able to completely dissolve within just a few hours of landing anywhere in nature, making this a remarkable device. You can learn more about this in one of the previous videos in the description. But now the same scientists and the same engineers from the same lab were able to develop something even more impressive than before. Something that used relatively similar principles, but an entirely different assembly approach, and more importantly, an entirely different technology. This time they created the smallest remote control robot that's ever been made by anyone. And actually they were able to create quite a few of them, and they all seem to work just fine. Although what makes this particular creation unique is the size of the robot. It's extremely small, sub-millimeter in size, but a robot that can be controlled remotely and can perform very simple functions and can definitely move around. Something that's actually kind of groundbreaking, something that's never been done before on these tiny scales. But in terms of the actual remote control technology, we're not really talking about something like this, something you might have used as a kid or might have used with your own kids. We're actually talking about an entirely different approach that by itself is also quite original. Hello wonderful person, this is Anton, and today we're going to be discussing this new study and the formation of this really incredible miniature robot that uses a very unique type of locomotion and can also be controlled in a very unique way. And even though it's technically still an experimental study, because the actual results are very promising, currently this technology has quite a lot of potential in a variety of different fields. But first, let's talk about the details of how this works and what exactly these little guys can do. So if you look at this picture really closely, you'll realize that there are no actual electronic parts and no radio receivers or any microprocessors. And so it obviously does not work using radio technology or using various types of controllers we normally use in electronic devices. Instead, this particular material relies on the idea of memory. These are usually known as the memory materials, also referred to as the shape memory alloy, or SMA, which are generally the materials which can return to their original shape if they suddenly find themselves in similar conditions to the original conditions where they were created. And so even though a material can maybe change its shape depending on the temperature, once this material is cooled down, it will then return to its original shape. So the main force that's used here is known as the elastic resilience. And so depending on the temperature, the shape will either return to its original value or it will open up and move to a different direction. Which means that in theory, by varying the temperature, it makes it possible to move certain parts around, and by using a very specific shape, in this case a crab or a spider, it then becomes possible to actually create something similar to typical locomotion. And so in this case, by hitting the robot in several different targets, it becomes possible to move it around, mimicking something similar to a crab walking sideways. And because all of this was done with a very specific type of laser, by using this laser and moving it in a certain direction, it also becomes possible to change the direction of motion. And so in other words, the actual motion is formed by a kind of a pulsation of the laser that continuously cools down and warms up various parts of the body, changing the elasticity of each of the limbs and thus performing a kind of a walk. And depending on the shape, a lot of different function can be created as well. In this case, the legs can bend, they can twist, they can expand, and thus in theory could easily mimic the locomotion of a typical insect, and even more complex motion found in more complex animals. But more interestingly, this particular phenomenon seems to work even faster if the object is even smaller. So by turning this into an even smaller crab, in theory it could move even faster and produce even faster motion. And because a single laser in this case could control all of them all at once, it does create a possibility to create a kind of an artificial swarm that could perform a lot of functions that would be otherwise difficult for anything bigger to perform. And so here we're talking about things like medical functions, for example, in repairing tissue, or maybe treating organs that would be otherwise inaccessible, or, as you can see from this video, maybe even some kind of a cleanup that would be too dangerous for humans, or possibly too difficult to achieve otherwise. Now obviously still it's just an experimental study, but the basic principles shown here are actually kind of brilliant. The fact that this even works is already quite amazing. With all of this being relatively simple as well. So basically by moving the laser left to right, the object moves in that direction too, changing the laser direction changes the motion, with the other major achievement being the manufacturing process itself. In this case, the scientists found a way to basically 3D print these structures directly by forming them in a kind of a filament origami construct that turns into this object directly without the use of anything else. And according to the scientists in this paper, they can technically use this process to create any walking robot of any size and any shape. Although the students working in this lab really wanted to create a crab, and surprisingly it worked really well. And so in theory, these micro-robots could one day transform our society in one way or another. But in more realistic terms, and slightly more relevant to the channel's main topic, NASA has actually recently discussed a potential swarm mission to objects like Europa or any other moon that has a very large ice sheet and an ocean underneath. And at least in theory, these robotic swarms could easily explore various objects much more effectively than a single probe. And interestingly, this particular proposition has already reached so-called Phase 2 in the NASA Innovative Advanced Concepts funding program, with this concept receiving $600,000 to research it even further. And although at the moment it's most likely going to be using larger electronic robots, relying on technologies we know work really well, in theory, the ideas from this study could actually allow us to create something even more impressive, and possibly even something much cheaper and much easier to deploy. Because unlike a typical rover, you could actually have like thousands or even millions of these inside even a smaller probe, or even inside one of the swarm probes, which could then launch these objects in no time and control them using lasers or a similar concept that uses heating and cooling. And so the future of space exploration could actually be all done by these tiny swarms with much smaller probes that, at least in theory, we could send to pretty much every major object out there in the solar system. Simply because it would be much lighter, much cheaper, and possibly even more effective in exploring much larger areas, with at least one animal on planet Earth even teaching us on how to do this effectively and how to create these swarms, which can then spread really fast across really large areas. So definitely quite an intriguing study, and quite an intriguing creation from the Northwestern University. But because this is still a prototype and just an early stage of this, we don't really know where any of this goes. For example, when it comes to these flyers, they're also still in a prototype stage, and they haven't really been used in anything major yet. And so for all we know, all of these might actually just stay some kind of a scientific or engineering curiosity and nothing else. I mean, hopefully they don't, but you never know. Nevertheless, I'm looking forward to more of the discoveries and creations from this lab, and I can only imagine what they come up with next, sometime next year, or what they end up creating with the current discoveries and the current technologies. On that note, once they do actually come up with something, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, and maybe robotic crabs, and support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.